This is a video from section 6.1. The directions say to sketch the region enclosed by the given curves and find the area. So let's take a look at number 19, and this is from the Stewart Calculus textbook, 9th edition. Suppose we're given y equals 12 minus x squared, and we're also given y equals x squared minus 6. And we need to sketch a graph of what this looks like. And so here's the y-axis, here's the x-axis. And what I want to do first is I want to sketch the graph of y equals 12 minus x squared. And so when x is 0, y is 12, right? And so I'm going to go 2, 4, 6, 8, 10, 12, right? So I'm going up by 2's. And so this is 12, and I'm going to plot 0, 12. And this is a parabola that's face down. And remember, we just need a rough sketch. And so I'm going to come around here and sketch the graph of y equals 12 minus x squared. So we can label that accordingly. Okay. Now, if we look at this second equation, when x is 0, y is negative 6. And so we're going to go down 2, 4, 6. And so this point here represents 0, negative 6. And we're going to sketch this graph. It's a parabola that faces up. And remember, it's a rough sketch, right? Okay, now, we need to draw a rectangle. So I'll draw one right here, for sake of argument, okay? Now, what's the height? That's my question. So the top equation is 12 minus x squared, okay? So I'm going to write 12 minus x squared. The bottom equation is x squared minus 6. So I'm going to subtract off x squared minus 6 to get that total height. And so if I distribute the negative, I get 12 minus x squared plus 6, which is 18 minus 2x squared, right? Now, what's the width? Now, remember, the width is dx. The width runs parallel to the x-axis, right? Now, we got the height, we got the width. We need to find these points of intersection. Okay, so we're going to do this mathematically because the graph, from a graph, it can be a little difficult to tell where these graphs intersect, okay? And so what I'm going to do is set 12 minus x squared equal to x squared minus 6. Add x squared to both sides, and we get 12 equals 2x squared minus 6. Add 6 to both sides. We get 2x squared equals 18. And so x squared equals 9. And then x equals plus or minus 3. Now we're ready for the punchline. Now we can get the area. The area is the integral from negative 3 to 3 of the height is 18 minus 2x squared. And we're going to integrate this with respect to width, dx. And so this is 18x minus 2/3 x cubed, evaluated from negative 3 to 3. Okay, now I'm going to replace x with 3. And we get 54 minus 2/3 of 3 cubed, if you will. And then we're going to subtract off. I'm going to plug in -3, and I'm going to get -54 minus 2/3 of -3 cubed. So if I take 54 and subtract off -54, that's 108, all right? And then I'm going to go minus 2/3 of 27. And I'm going to come over here, and I'm going to subtract a negative, which just basically means add. So I'm going to add 2/3 of -27. And so this is 108 minus 18 minus 18. And so what would that be? 72. And that's how we do problem number 19. Let's take a look at this problem. We'll take a look at 26. So I want to take advantage of a bit of trigonometry with you guys. And so here we get y equals cosine x, right? And y equals 2 minus cosine x. Now, x is less than or equal to 2 pi, and it's greater than or equal to 0, okay? Let's draw a picture. Here's y. Here's x. Now, I'm going to address y equals cosine x first. When x is 0, cosine of 0 is 1. That means we're up here. When x is pi over 2, y equals... So let's try this again. When x is pi over 2, y equals 0. When x is pi, you're at -1. At 3 pi over 2, you're back up to 0. And at 2 pi, you're at 1. And so it's doing something like this. Okay, so this is y equals cosine x. Now we're going to do y equals 2 minus cosine x in red. When x is 0, y is 1. So it looks like we're in the same spot. When x is pi over 2, my corresponding y value is 2, which means we're up here. When x is pi, we're at 3. Cosine of pi is -1. Okay? And then 2 minus a -1 is 3. So we're going to come up to here. When x is 3 pi over 2, we're back up, we're back down to 2. And when x is 2 pi, we intersect with the y equals cosine x graph. So it looks like we're coming here. It appears. Which is pretty interesting. And we could even make sure we're supported by that, because now if you look, if I let cosine x equal 2 minus cosine x, right? This says 2 cosine x equals 2. And so cosine x equals 1, and the only way that's going to happen is when x is 0 and x is 2 pi. And I'm only talking specifically on the interval 0 to 2 pi. Now, check this out. If we draw a rectangle here, I want to know what's the height, and then what's the width. And so I'm going to do this every single time. So the height, the top function is 2 minus cosine x. The bottom function is cosine x. So it's 2 minus cosine x, the top function, minus the bottom function. The width is dx. So you get the area is the integral from 0 to 2 pi of 2 minus cosine x minus cosine x with respect to x, which is the integral from 0 to 2 pi of 2 minus 2 cosine x dx. Now, this is 2x minus 2 sine of x from 0 to 2 pi. Now, remember, sine of 2 pi equals 0. Sine of 0 equals 0. So this second term isn't going to contribute much of anything. So the correct answer here for problem number 26 is 2 times 2 pi, which is equal to 4 pi. And that's going to conclude this video for section 6.1. And we looked at 2 examples, specifically number 19 and number 26 out of your textbook. Okay, thank you.